Let's wrap up our adventure of looking at this 2014 released AP Calculus AB exam. These are the last two questions on the No Calculator Allowed section, the free response, numbers 5 and 6. So let's look at number 5. We have a particle that is moving on an x-axis, so you can think about it going left and right at time t according to this function. First question just says, is the particle moving left or to the right at t equals 1? So what are we going to look at here? The first derivative, because the first derivative tells us direction, right? It would be the velocity. And if the first derivative is positive, we know it's going to the right. If it's negative, we know it's going to the left. So let's find the derivative. X prime of t would be velocity, by the way. And that would be 15t squared minus 18t plus 0. Just doing that power rule. You plug 1 in here. T equals 1, t equals 1. You get 15 times 1 squared minus 18 times 1. Boy, that sure looks like negative 3. That sure looks like negative 3. Now, is that positive or negative? Well, that's an easy question, right? That is negative, so this thing is moving to the left. So the particle, you always have to actually conclude by stating your answer. The particle is moving to the left since x prime of 1 equals negative 3, which is less than 0. And that should be enough to do it. Yep, I'm looking at the rubric, and sure enough, that's exactly what they want you to say. All right, at what time t, let's look at the next question here. At what time, I'm looking down here, at what time t is greater than 0 is the particle furthest to the left? So let's take our velocity, our x prime function. It's 15t squared minus 18. Let's find the critical values, like where it changes sign if it does, and that'll be when it turns around. When the velocity changes sign, the original object must have turned around. So we're going to set this equal to 0. You factor out a 3t, right, and that leaves behind 5t minus 6. So t equals 0 is a critical point, and so is t equals 6/5. Right, so you now need to determine whether it's going left or right. Now we already set up above, right up here, we said at 1 it was going to the left. Okay, let's try a bigger number, like after 6/5. If you plug 2 or 5 or whatever in here, what ends up happening is you get a positive number. Okay, so since x prime is less than 0 for t equals 0 to t equals 6/5, the particle is moving left. For t greater than 6/5, the particle is moving right. So at t equals 6/5 is when the particle is furthest left. And I know I wrote a lot there. You could probably summarize that a little better. But you have to really lay out your reasons for that. Since the derivative is negative from 0 up to 6/5, And then from 6/5 to infinity, the derivative is now positive. So then it's moving to the right. So it must have been furthest to the left at 6/5. Now notice in the question, it doesn't say how far to the left does it go. It just wants the time. So don't do extra work here. They just want the time. Okay, question C. A second particle, y, moves along a y-axis, up and down, all right? So that the position at time t is given by the function here. At any given time, the origin and the positions of the particles are in the first quadrant alone. Find the rate of change of the area of the triangle. So you got a particle up here that's operating according to y of t, and then, of course, the stopwatch is ticking, right? And the same t is down here. This is x of t down here. This forms a triangle in the area of the triangle. So the area of a triangle would be 1/2 base times height. 1/2 base times height. We have to find the rate of change of the area. See, so that's a prime at 1 equals question mark is what they're asking us to do here. So we have to take the derivative of this. And this will be 1/2 times the first times the derivative of the second. Now remember, we did the derivative of the second up above here, and that was 15t squared. 15t squared. I got to go ahead and put y of t in there. 15t squared minus 18t. And then plus, we'll put the 1/2 there again, the derivative of y, so y prime is 7 times the original function, way the heck back here in the original problem, 5t squared, or t to the third, plus, here I'm going to just copy this, my short-term memory is just horrible. I'm going to paste that down here so I can see it. This would be 5t to the third minus 9t squared plus 7. All right, let me move all of that to the left so that you can actually see what I'm doing, right, on the screen here. There we go. All right, so I had to do the product rule. The product rule. Don't forget the 1/2 on the second side. Now, do I have to spend a lot of time doing algebra here? No, because they are asking us to just plug in t equals 1. Now that we've done the calculus, we can plug in t equals 1. So we get 10 times, so a prime of 1 equals 1/2 times 10 times 15 minus 18. See, they chose the number 1 because it ends up working out relatively well, times, and then we have 5 minus 9 plus 7. So this is 15 here. Actually negative 15. Always do those calculations twice. This is negative 3 times 10, that's negative 30, divided by 2 is negative 15. Over here we have negative 4 plus 7. Negative 4 plus 7 is 3. So this would be plus 21 halves. Okay, so that would be negative 30 halves if you're doing this in your head, right? You can't use a calculator, so you just be careful. We put all this time in this. We want to get it right. This would be negative 9 halves. Negative 9 halves. Now, do we have any units in this problem that we need to use? I don't see any. So according to the rubric, that's what we need to do. Just show our work. The rubric says showing the area function. That's this right here. And then it says the derivative, the two derivatives. So I showed my 2 points for the derivative. Here's the derivative that they're looking for, and then the third point for the answer. Right, and that's part D, or part C, I mean. Not too bad. All right, question number 6 here. Consider the FRQ, the differential equation that's given. And then, of course, f of x, y equals f of x would be the particular solution to the FRQ, with the initial condition where 1 turns into 2, 1 comma 2. That point will allow us to solve for c when we're solving the differential equation. Find the slope of the line tangent. Well, remember, this does mean slope right here. So we have the slope machine or expression. All we have to do is plug in. We just have to plug in 1 and 2. So this would be 1 minus 2 over 1 times 2 minus 1. That all looks like that would all be negative 1. And that is the correct answer. See how easy that is? So the slope is right there. All right, on the axes provided, do the slope field. So I'm going to copy this here so that I can bring it down here and talk to you about it. All right, so here's my function, or at least my derivative, right? So we're going to do all these things. Do you notice some things that I start to look for is that I see that at y equals 1, all the slopes are 0. So I would put a horizontal here, and here. Now, one question is why aren't there dots here? Because you're not allowed to plug 0 in. It doesn't exist there. So there is no derivative there. Okay, so then let's keep going. What about if we plug x equals 1 and y equals 0 in? That would end up being negative 1. So that would be positive 1. So right here, let me erase my circle, we would put a positive 1. Now let's plug 2 in for x, and y is still, so 1 minus 2 over 4, y is still 0, so we're still going to get a negative 1 here. Okay, so that would be negative 1/2. So if you go to the right here, did I get the wrong sign? That would be positive 1/2, or negative. Let's see. 1 minus 2 is negative 1 times negative 1, so that one was right. And then 1 minus 1/2 is positive times a negative. I think we're good. I think we're in good shape. This is negative 1/2, which means this would be sort of like this right there. And I just looked at the answer, and that's right. I didn't want to look at the answer until after I checked it. My spidey sense was going off, my mathematical spidey sense, I like to call it. All right, so let's now plug in x equals negative 1. So that would be 1 minus 2 over negative 1 squared, once again, times negative 1, because we're plugging in negative 1 comma 0. So that would be 1 minus 2, which is negative 1. So that would be positive 1 again. So right here, we have a positive 1. Okay. Now, let's continue on. What about 2 comma 2? That would be this point right up here, 2 comma 2. So we plug that in, 1 minus 2 over 4 times 1. Well, that's 1/2. So that's going to be up like that. What about plugging 1 in? 1 minus 2 over 1, all times, I'm doing 2 minus 1 again, so y is 2. So times 1, that's negative 1. So we're down like that. We have one more dot to do. We need to do this point over here. That's negative 1 for x. So that would be 1 minus 2 over 1 times and then it was our y value there is 2, so 2 minus 1 is 1. So that's negative 1. So it would look like that. Right, I noticed that we had some symmetry on the left compared to the right. Right, and that's another thing that you can start to notice, but it was not so hard to brute force that, honestly. All right, moving on to number C. We are almost done. Part C, find the particular solution to the differential equation. So this is where you're going to actually solve it by doing an antiderivative. And how do you do this in a case like this? You do separation of parts here. So we're going to move the y minus 1. We're going to divide both sides by y minus 1 is what we're doing. And all of that equals 1 minus 2 over x squared dx. So you get 1 point on the AP exam for writing that, for separating your variables. Now we're going to integrate both sides. This is the natural log of y minus 1 equals x. All right, so the exponent here, this is 2x to the negative second, is what this is right here. So we have to add 1 to the exponent, that's negative 1, divide by the new number. So we get minus 2, but it's going to become plus 2 because of this already minus, right? Plus 2, and it's going to be over x. And then plus c, plus c. All right, so you get a point for doing that. Now we're going to solve for c. We use the initial condition here. So we plug 1 in for x. We plug 2 in for y. Plus c. So the natural log of 1 is 0 because anything to the 0 power is 1 equals, this is 3 plus c. So c equals negative 3. All right, so you go ahead and write that in. The natural log of the absolute value of y minus 1 equals x plus 2 over x minus 3. All right, now what do you do? Now what do you do? Are we done? It says find the particular solution with y all by itself. So the last point here, I'm looking at the rubric. To get the final point, to get the 6th point here, we have to solve for y. And the way you do that is a base e. You put a base e on both sides, you're left with y minus 1 all by itself. So then if you add 1 to both sides, you get 1 plus e to the x plus 2 over x minus 3 power. And that is what we call the particular solution. And that is the correct answer. I'm looking at it here on the rubric. We got all 6 points. All right, hopefully you found this video and all these videos in the playlist and into the compilation video useful. And check out my other videos to help you review for the AP exam. All right, good luck. I'll catch you later.